The circuit board is where the electronic components are located, along with the electrical connections which power them. In a larger device such as a computer, the circuit board is typically rigid. When the device is compact like a small camera, the circuit board must be flexible. It needs to fold to fit inside. Flexible circuit boards are so thin and pliable, they're nicknamed origami circuitry, after the Japanese art of paper folding. At the core of the boards is a hair-thin polymer film that's both bendable and heat-resistant. The manufacturer produces this material for several industries. In this case, they cut rolls of it to the width required for making flexible circuit boards. With a rigid sheet of paper lending support from underneath, the film enters a machine which sandwiches it between two thin sheets of copper. A cutter then slices the sandwich into rectangular sheets. A cushion of air pumped through the conveyor belt literally floats sheet after sheet off the machine and into a stack. Each three-layer sheet is separated from the next by the support paper called a laminate. The film at the center has a heat-activated adhesive coating, while the adjoining copper surfaces have been chemically roughened to enhance adhesion. After drawing the layers tightly together with a vacuum, workers place the laminates in a high-temperature, high-pressure chamber for several hours. This activates the adhesive, bonding the layers. To test the bond strength, they burn some adhesive off a sample of finished laminate to pry apart the layered edge. Then they grab the top copper layer with this pulling device and measure the strength required to peel it off the film. The laminates now ship to a circuit board factory. Here, computer-guided machines cut them into specific sized panels and drill tiny holes for mounting the electronic components. Then a coating machine uses a combination of heat and pressure to apply a light-sensitive fluid to the panel surface. Technicians load the panel into an exposure machine, in which a computer-guided laser scans the circuitry pattern onto the coated surface. A laser is a beam of focused light, so wherever it hits, the fluid reacts and hardens. The dark areas of unexposed fluid remain soft. The next machine acid washes the soft areas, removing both the fluid and the copper layer underneath it. Now the only copper remaining on top of the polymer film is in the circuitry pattern. This inspection device meticulously checks every single copper circuit. Next, they remove surface dust with a sticky roller. The panel must be pristine before receiving the sheet of electrical insulation, a mere 25/100ths of a millimeter thick. Technicians use a magnifier to carefully match up alignment holes on the film with corresponding alignment holes on the panel. By activating the film's built-in adhesive with a soldering iron, they tack the insulation to the panel at key spots. The next step is to fully laminate the insulation to the panel. Technicians sandwich two panels at a time between sheets of protective plastic. This protects the surfaces from the heat and weight of the lamination press. As it forces the insulation film deep down onto the panel, it encapsulates the circuitry. They load the panels into the lamination press, apply a vacuum to remove the air between the layers, and start her up. For the next hour and a half, the press simultaneously applies high pressure while heating the panels to 400 degrees Fahrenheit. When the panels cool and come out of the press, technicians place one at a time on a circuit board-shaped die. Then they release a press, which forces the panel onto the sharp die, slicing away the excess material. The flexible circuit board is now ready for the company that installs the electronic components. There are two ways to mount components: solder them directly onto the board surface, or solder tiny prongs underneath the components known as leads into the board's mounting holes. A flexible circuit board can have as few as a dozen components, or as many as 500. Technicians can solder larger ones magnified under a microscope. But only robots can solder smaller ones, because they're so tiny and barely visible to the human eye. If you have any comments about the show, or if you